Hey guys, in this question we'll be looking at derivatives. So I chose a question here that is very similar to something you'll see on a final exam, where you'll see a tough derivative question with lns in the exponent. So where do we start, solving this question? So remember that sometimes they'll give you a derivative in the form of f of x equals something, and they'll ask you to derive, or they'll ask you simply y equals something, and you'll have to derive this side. Remember, when you derive one side, you got to do it to the same side, right? You got to do the same thing to the other side. Just remember that. So, let's look at this question. What's the first thing we'll need to do? Before you derive, there's always something that you might want to do. The first thing, as soon as you see lns, is you might have to simplify. So remember that. So how am I going to simplify this? So, my first step is going to be to simplify. So I'm going to simplify this by bringing down my exponent, which has a ln in it. Now remember, to bring down exponents with a ln, what do? You take the ln of both sides. And watch what happens. So I have to take the ln of my left side. In doing so, here I'm taking the ln of my entire right side. So what happens when you take the ln of something? Two things happen. Your exponent comes down. So remember that. The first thing that happens is your exponent comes down. By your ln of 6x plus 1. Don't forget the brackets here. Right? So what did I do? My ln 10 plus 1 divided by ln 6x plus 1 comes down. The second part is you multiply by the ln of the original base. So, two parts. When you take the ln of both sides, essentially this part will be the ln of whatever was there. On the right side, when you take the ln of this entire expression, the exponent will come down, and you will multiply by the ln of the original base. That's all. A trick to help you is that this, or the denominator of any number, is always 1. And that's step 1. Just to make sure, guys, this is a 1, not a 6. Okay? Step 2 now, remember, you haven't derived yet. So here you've simplified. Here, you're ready to derive. Okay, so you might want to write it down, simplify, and here, you're deriving. So when you actually derive, what is going to happen? Let's just look at the right side, okay, for now. When you derive this, essentially you'll have ln y, and you're going to do a derivative of that, okay? Let's keep that as such. On the right side, you're going to derive this entire expression. Okay, now remember, ln 10 plus 1, that's nothing more than if I had, say, the number 10 here, or 5. When you do derivatives of integers, you don't touch them. Let's remember that. So you will leave this as ln 10 plus 1. Again, because you do not derive numbers. You leave them separately. Okay. Divided by the ln 6x plus 1, you can derive 6x. What is the derivative of ln 6x? Remember, it is 1 divided by 6x multiplied by the derivative of the inside. Right? Let's remember that. The derivative of ln is 1 divided by the term multiplied by the derivative of the inside. So 1 over 6x multiplied by 6. And this is all multiplied by ln 18x, same thing as ln 6x. We will get 1 over 18x, brackets, multiplied by 18. Right? And your denominator is 1. So, what's going to happen here? Essentially, you'll be able to cancel out a few things. This will cancel with that. This 6 will cancel with that 6. You will be left with ln 10 plus 1 divided by 1 over x multiplied by 1 over x, right? Over 1, but you don't have to put it. What happens here? Cancel. Cancel. So what are you left with? You're essentially left with ln y prime, which means the derivative of this term. We haven't touched this yet, okay? Equals ln 10 plus 1. So, what's going to happen at this point? Are we done? No, because what is the sign for derivative when you have y? It's just y prime. We don't have y prime. We have ln y prime. So the question is, how do I get rid of ln? Now remember, to bring down an exponent, you take the ln, but to get rid of a ln, you take the e. So I hope light bulbs went on here. You take the e, 10 plus 1. So make sure you're copying this down. What happens here implicitly? The e and the ln cancel out, and you're left with y prime, right? And this part, you essentially will be left with, you can actually find this on your calculator, put e to the power of, and make sure you put your brackets, ln 10 plus 1, you will get something to the effect of 27.18. So make sure to put this in your calculator, e to the exponent ln 10 plus 1, and you are done. So if we can recap, when you have a tough looking question like the one I gave you, y equals 18x to the power of ln 10 plus 1 over ln 6x plus 1, what you first have to do to a question like this is simplify it. Don't go right away trying to do product rule or chain rule or whatnot. Just simplify it. Bring down the exponent by taking the ln of it. Remember that when you take the ln, you bring down the exponent and you multiply by the ln of the inside. And you remember that what you do to one side, you must also do to the other side. Therefore, you take the ln of that side as well. And then you remember that the ln of an integer, the derivative of the integer, you leave it alone, right? And that's what we did here. The derivative of a ln is 1 over what was inside, multiplied by the derivative of the inside, which is what we have here. Same thing for this term. And then you can essentially cancel because you have a multiplication sign in between. What are you left with? Ln 10 plus 1. And remember that on the left side, you want just y prime because they're asking you to derive. Therefore, you must get rid of the ln. How do you do that? You take the e of both sides. And in taking the e of both sides, the e and the ln's cancel out, leaving you with y prime equals this answer in your calculator. And you are done.